Hello everyone, welcome back to my channel Explain Maths. In today's video, I'm excited to start off the grade 10 syllabus, which follows the revised NCERT pattern. I am going to break down the concepts in a simple and easy to understand way, which helps you in preparing for your exams. So in today's video, I'm going to start with first chapter of grade 10, which is real numbers, and I will be covering the introduction of this chapter as well as I will solve few example sums. If you haven't subscribed my channel, make sure to hit the subscribe button for more helpful content. Let's get started. So already you have studied rational number and irrational number in grade 9, isn't it? So let's do a quick recall of what is rational number and what is irrational number. So rational numbers, if you see, rational, the word rational comes from the word ratio. If you can see here, the first 5 letter is ratio, isn't it? So rational comes from the word ratio. That's why we represent rational number in the form of a fraction, isn't it? Now, rational number is a number which is written in the form of p by q, where p and q are integers and q should not be equal to 0. Why? Because if q will become 0, we know that any number divided by 0 is undefined, isn't it? So q should not be equal to 0, and such form of representation is there for the rational number. Okay, so the rational number are the numbers which is represented in the form of p by q. It is denoted by the letter q. So all the decimal number, all the whole number, all the natural number can be represented in the form of p by q. Now how? So suppose if I have taken a natural number 2, I am telling this 2 is also a rational number because I can write this 2 in the form of 2 by 1. Now it is in the form of p by q, isn't it? This is p, this is q, and my q is not equal to 0. In fact, 0 is also a rational number because 0 I can write as 0 by 1 or 0 by 2, anything. And again it is in the form of p by q and my q is not equal to 0. P can be 0 but q should not be equal to 0. This is your rational number. Now, every rational number is expressible either as terminating decimal or as a non-terminating recurring decimal. Now, what is the meaning of terminating and what is the meaning of non-terminating recurring, that we will see now. Okay. So, rational number is expressed either as a terminating decimal or as a non-terminating recurring decimal. We will see these terms one by one. So first is terminating. Now terminating means a decimal that ends after a finite number of digits. Okay, means after few digits when you divide it, after decimal point you will get few digits and then you will get your remainder 0. This is the meaning. Finite means something which you can count. So let's take one example. So I have taken 2 by 5. Now I'm going to divide it as 5. 5 is my divisor. Okay, now 2 is smaller than 5. I cannot divide it, isn't it? So I have to put here 0. Now next, I don't have any number after 2. So I can put a decimal point and I can write here 0. Now I will bring down this 0. So 5 times 4 is 20. So here you can see that I have got my remainder 0. And after decimal point, it has got only one digit, 0.4. Now I should not proceed it further. So it terminates here. So that is the meaning of a terminating. Now next is what is the meaning of non-terminating recurring. It means that a decimal in which a digit or a set of digit is repeated periodically. Means it will never terminate, but either one digit or some set of digits keeps on occurring when you divide. So let's take some example for this. First I am going to take one example, 2 by 3. Okay, so I have to divide here. 3 is the divisor. Okay, now it is 2 is smaller than the divisor, so I cannot divide it. I am going to put it 0. Now 2 can be written as 2.000. Okay, because it is nothing but it is the equivalent decimal of 2. Now I am going to bring down 1 0 at a time down. So 3 times 6 I am getting 18. Again if I subtract, I am getting 2 as a remainder. Again I am pulling down another 0 here. So again 3 times 6 is 18. Okay. Now again I am going to pull down another 0. Again 3 times 6 is giving me 18. And again the remainder is 0. So what you can see, this 6 keeps on coming, isn't it? If I proceed it further, the 6 keeps on coming. It will never terminate. Okay, and it is recurring also. The same digit 6 is coming again and again. So this is the meaning of non-terminating, repeating, or recurring decimal. And such type of number I have to represent it is like 0.6, and on top of 6 I have to put a bar which tells that this 6 keeps on occurring. Okay, so here only one digit is occurring. Now I will take an example where more than one digit will occur. Okay, so let me take an example 3 by 11. So I'm going to divide it. So 11 times 3. Now 3 is smaller, I cannot divide it, so I'm going to put it 0 here. 3 I can write as 3.0000 like this, isn't it? Now I'm going to pull down one 0 here. Now 11 times 2 is 22. So my remainder is going to be 8. Now I will bring down another 0. 11 times 7 is 77. Now again I am getting remainder as 3. Now I am going to pull down another 0 here. So 11 times 2 is 22. My remainder is 8. Again I am going to pull down another 0 here. So 11 times 7 is 77. So again I am getting here remainder as 3. So now this is keeps on occurring, and which digit is repeating here? 27. 27 is keep on repeating. So here I will write it as 0.27, and I will put a bar on both 2 and 7, because here 27 is keep on coming. So this is the meaning of non-terminating, repeating, or recurring decimal. So hope it is clear now what is the meaning of terminating decimal and what is the meaning of non-terminating, repeating decimal. Isn't it? This all I think you have already studied in grade 9. Just I am doing a quick recall of it. Now we will see what is the meaning of irrational numbers. Till now we have seen rational number. Okay. So the rational numbers can be terminating or non-terminating, repeating decimal. Now what is irrational numbers? So irrational numbers are numbers which can neither be expressed as a terminating decimal nor as a repeating decimal. Okay. The rational number which is neither be expressed as terminating nor as a repeating decimal is known as irrational number. So let's see some of the example of that. So one of the very popular example is the value of pi. Okay. Sometimes we use the value of pi as 22 by 7. That is an approximate value. And if I say only 22 by 7, that is a rational number. But actually the value of pi is 3.141599265 and so on. It is never ending. It is not terminating. It is not repeating also. You can see after 5 also the digit will keep on coming. Okay, and none of you can see here the digits are not repeating also. So this is irrational number. Same way root 2 and root 3. The value of root 2, if you see, it is 1.41421356 and so on. Root 2 value is 1.41421356 and so on. Same way the value of root 3 is 1.73205080 and so on, isn't it? So they are the example of irrational number. Now we will see then what is real numbers. So real numbers are the combination of rational and irrational numbers. So in our number system we have already studied. We have natural number, we have whole number, we have integers, we have rational numbers, irrational number. Now on top of that we have a real numbers. And real numbers are the combination of rational number as well as irrational number. And it is represented by the symbol R. Okay, it is represented by the symbol R. So hope it is clear. Real numbers are the combination of rational and all the irrational numbers. Okay. Now we will see the Venn diagram of our number system. So here I have written it is a combination of rational number and irrational numbers, right? Now this is our number system. If you can see, on top of that we have real number. And real number is a combination of rational and irrational number. Now under rational number we have integers, whole numbers and natural numbers, isn't it? So in the smaller classes we were studying only natural numbers, isn't it? Till grade 4 or 5 you have studied only about natural number. Then slowly you have studied whole numbers and integers in grade 6. Then grade 7 onwards you have started studying rational number also. And when you reach grade 9 you have studied irrational number also. Now you are in grade 10 and you have studied real numbers. So real numbers are the collection of all the rational number and irrational number will give you the real numbers. Okay. Now we will see next topic. Now we will see the fundamental theorem or theorem of arithmetic. So this theorem tells that every composite number can be uniquely expressed as a product of primes except for the order in which each prime factor occurs. So what is the meaning of composite number? First of all, you have already studied this from grade 4 onwards, isn't it? Prime number, composite number. So composite numbers are the numbers which is having more than two factors. So this theorem tells that for any composite number, you can express it as a product of prime numbers and accept the order in which these prime factor occurs. So it can be any order, but finally you are able to express the composite number by using those prime numbers only, isn't it? So let me give you one example. Suppose I have taken one composite number 504. Okay, I have taken this composite number 504 and I am going to write this 504 as a product of prime. So I will do the prime factorization. This you all know from grade 4 onwards. Okay, so always start with the smallest prime number. So smallest prime number is 2. So 2 table when 504 comes, it comes 252 times. Again, I am going to use 2. So 2 ones are 2, 2 twos are 4, 2 6 are 12. Again 2, so 63. Now 63 won't go in a 2 table. So now I have to move to next prime number which is 3. So 3 times 21, 3 times 7 and 7 itself is a prime number. So 7 times 1, isn't it? So I can write this in the form of 2 into 2 into 2 into 3 into 3 into 7. And this further I can write as 2 comes here 3 times. I can write it as 2 cube into 3 square into 7. So you can change the order of these prime numbers, but these will be the only prime number when you factorize it. Whatever is the order of the prime number, you will get 3, 2, 2, 2, 3 and 1, 7 only. This is fixed. That's why it is given. Each composite number is uniquely expressed. Okay, there is no other way to get another factorization of this. It will be same. Only the change will be in the order of the prime numbers. So that is the meaning of this fundamental theorem of arithmetic. Okay, so hope it is clear. Now, in general, if any composite number is given, suppose x, so here my x is 504, we can factorize it as p1 into p2 in dot dot pn. Like this, how I have written here. See, I have written here, now 504 is my composite number. Here I have written as 2 into 2 into 2 into 3 into 3 into 7, where p1, p2 to pn are prime. So you can see here 2, 3, 7 are my prime numbers written in ascending order. So here also I have written in ascending order, isn't it? So when I write in ascending order, it may be same or it will be greater than that, isn't it? Can you see here? It is less than equal to. Okay, so you have to follow this order. And if we combine the same prime, we will get powers of prime. So if you see here, the same prime number 2 I have combined and I have got it as 2 to the power 3. Here also the same prime 3 I have combined and I got 3 square into 7, isn't it? So this is the meaning of these terms. Now here I have taken one more example where 32,760, if I do prime factorization, I can write it in this form. And here you can see there are 3 times 2. So it is written as 2 cube. 2 times 3. So it is written as 3 square. And then 5, 7 and 13 is 1 time. So it is 1 time. So once we have decided that the order will be ascending, then the way the number is factorized is unique. Okay, so always it is advisable to write the prime factorization in ascending order. And this is the unique way. If you fix that no, you have to follow ascending order, now there is no other way to represent the composite number. Isn't it? This order is now fixed. It's a unique. Okay, but you have to decide whether you will follow ascending order or not. If you are following ascending order, this is only the unique way. If you will not follow any order means, then also it will be unique. Only the order of prime numbers will be changed. But there will be 3, 2, there will be 2, 3, and there will be 1, 5, 1, 7, and 113, whatever way you factorize. That's why it is given that it is a unique way to represent a composite number as a product of prime, isn't it? So hope it is clear now. Now next we will see how to find the HCF of two numbers. So HCF of two numbers is the product of the smallest power of each common factor in the numbers. Okay. So let me explain this by giving one example. So I am going to find the HCF of 6 and 20. So as we have to find the smallest power of each prime factor of the number, so my first step is to find the prime factor of 6 and 20, isn't it? So if I factorize 6, so my prime factor for 6 I will get it as 2 into 3. And for 20 if I do, the prime factors will be 2 into 2 into 5. This further I can write as 2 square into 5. Now according to the definition, it says that HCF of two numbers is the product of the smallest power of each common prime factor. So if you see this 2 into 3 and 2 square into 5, I can find only one common prime factor, which is my 2. So I have to take the smallest power of that. So in 6, the power of 2 is 1. In 20, the power of 2 is 2 only, isn't it? So my smallest power is 1. And there is no other common prime factor. So my HCF is 2 only. Clear? Now moving to LCM of two numbers is the product of the greatest power of each prime factor involved in the number. LCM is greatest power of each prime factor. See the difference. For HCF, it was the smallest power of each common prime factor. Here the term common is not there. So whatever prime number you will get, okay, the greatest power you have to take. So if I take the same example, LCM of 6 and 20. So 6 I have to write as 2 into 3, and 20 I can write as 2 square into 5. So according to definition, if I have to find the LCM, so it is the greatest power of each prime factor. So here my prime factors are 2, 3 and 5, isn't it? In 6, the prime factors are 2, 3, 2 and 3, and in 20, one of the extra prime factor is 5. I have to take the greatest power of it. Now in both 6 and 20, my greatest power of 2 is 2 only, right? And the greatest power of 3 is 1, greatest power of 5 is 1. So greatest power of 2 is 2. So I will write here 2 square. Greatest power of 3 is 1, 5 is 1, so it will be remain as it is. So now it will be 4 into 3 into 5, which will give me 12 into 5 equal to 60. Okay, so this is the LCM of 6 and 20. So HCF of 6 and 20 I got as 2 here, and LCM of 6 and 20 I got it is here as 60. So hope it is clear now. Now next we will see the relation between HCF and LCM with the numbers. So now I am going to show you the relation between HCF and LCM of two numbers. So just now I have find out the HCF of 6 and 20 as 2, right? And LCM of 6 and 20 as 60. Now if I multiply these numbers 6 and 20, so the product which I will get it as 6 into 20, which is equal to 120, isn't it? 6 into 20, if I multiply these two numbers, I will be getting 120. These are the numbers which I have used to find the HCF and LCM. And if you notice the HCF and LCM, the product of HCF and LCM, if you are going to find it, HCF was 2, LCM was 60. Here also I am getting it as 120 only. So the product of the number 6 and 20 is also I am getting 120, and product of HCF and LCM also I am getting it as 120. So for any two positive integers A and B, the product of HCF and LCM is equal to the product of the number. So this is a relation. Now this relation is very helpful to find out the answer of some of the question. When you will solve the exercise, you will get a question where it may happen that LCM is given of the two number, you have to find HCF, or HCF is given, you have to find LCM. So like that you will get some question to solve. So in that case you can use this relation and you can solve it. Okay, so now we will solve one question which will be based on this. So the relation between HCF and LCM of two number is given as the product of HCF and LCM of those two number is equal to the product of the number itself. So if you take any two number, okay, find the HCF, find the LCM, the product of HCF and LCM is equal to product of the number itself. Okay, so now we will see this in detail by taking one example. So this is one example question. You have to find the HCF of 96 and 404 by the prime factorization method. And after finding HCF, you have to find LCM. So here, once I get the HCF, I can use this relation to find the LCM, isn't it? So let's start. First, we have to do the prime factorization of 96 and 404. So if I do the factorization of 96, I will get here as 2 times 48, then 2 times 24, 2 times 12, 2 times 6, 2 times 3, and then 3 times 1. So 96 I can write here as the power. Now 2 I am 2 how many times here? It is 5 times. It is 2 to the power 5 into 3. This is the prime factorization of 96. Now we have to do the prime factorization of 404. So 404, if I do the prime factorization, I will get 2 times 202, then 2 times 101, and 101 itself is a prime number. So 101 times 1. So here I have to write it as 2 square into 101. Now what is the HCF then? Highest common factor. Just now I told the definition. HCF of two number will be the smallest power of the common prime factor. Now common prime factor is only 2 here, and the smallest power of 2 is 2. So the HCF is 2 square, which is 4. Now I have to find the LCM. So if I use this relation, from here I will get the formula to find the LCM. LCM will be A into B divided by HCF of A and B. So I'm going to use that formula. So LCM of 96 and 404 will be equal to product of the number, which is 96 into 404 divided by HCF of 96 and 404. Now, don't multiply the number now, okay? Multiplication should be done only at the end. Now, HCF is 4. I got here HCF 4, right? Now, 4 times 101. And 96 into 101, if you do, you will get 9696. So, this is the LCM of the number 96 and 404. So, hope it is clear now. Now, this question I have taken from example question of NCERT textbook. So, you have to find the HCF and LCM of 6, 72 and 120 using the prime factorization method. So, till now we were finding out HCF and LCM of two numbers. Now, you have to find the HCF and LCM of three numbers. Okay. So, let's start doing the factorization. So, the prime factorization of 6 is 2 into 3, isn't it? And the prime factorization of 72, let's do it. So it will be 2 times 36, then 2 times 18, 2 times 9, 3 times 3, and then 3 times 1. So 72, I can write it as 2 cube because 2 has come 3 times and 3 square. See, 2 has come 3 times and 3 came 2 times. So 2 cube into 3 square. Next, I will do the factorization of 120. So 2 times 60, 2 times 30, then 2 times 15, 3 times 5, and 5 times 1. So 120 I can write it as 2 cube into 3 into 5. Okay, because here 2 came 3 times and 3 and 5 came one time. So I am doing the factorization like 2 cube into 3 into 5. Now, according to the definition, how to find HCF? HCF is the product of the smallest power of each common factor. So first of all, you identify what are the common prime factor. So common prime factor, you can see 2. 2 is present in all the 3, and next is 3. 3 is also present in all the 3 numbers. So my common prime factor is 2 and 3. Now you have to take the smallest power of both. So smallest power of 2 here is 1. Okay, and the smallest power of 3 also here is 1. So HCF is 2 into 3, which will give me 6. Now to find the LCM, it says that the product of the greatest power of each prime factor. So what are the different prime factors in the factorization of 3 number we got as 2, 3 and 5. Now for these 3 numbers, you have to take the greatest power. So greatest power of 2 is 3. You can see here 3 is here and 3 is here. And greatest power of 3 is 2, which is here. And greatest power of 5 is 1. So from here you will see it is 2 cube, which is 8. 3 square is 9 into 5. So 8 into 5 is 40 and 40 into 9 is 360. Now for two numbers we have found a relation, isn't it? The product of the two number is equal to product of HCF and LCM. So here also if you find the product of 672 and 120, what you are going to get? You multiply 672 and 120. You are going to get the product as 51,840. And the product of HCF and LCM, if you do, HCF is 6, LCM is 360, you are going to get 2160. So here you can say that product is not equal to HCF, product of HCF and LCM, isn't it? It means this relation is true only for two numbers. For three numbers, it is not satisfying this relationship. So the product of three number is not equal to the product of their HCF and LCM. Clear? So actually you have to solve this question till here only. I have moved forward to show you that the product of three number is not equal to product of their HCF and LCM. Okay. Now next example. Consider the number 4 raised to the power n, where n is a natural number. Check whether there is any value of n for which 4 to the power ends with the digit 0. Okay. The question says that is it possible to take any value of n such that it is a natural number and the number will have 0 in the unit place. Suppose 4 is square. 4 into 4 16. 0 is not there. Now take another value of n and then you check, are you going to get 0 in the unit place? So first of all, you try to observe some pattern. Let us take some number which is having 0. So 10 is having 0, 20 is having 0, 30 is having 0, right? Now if I do the prime factorization of 10, I am getting 2 into 5. 20, I am getting 2 into 2 into 5. 30, I am getting 2 into 3 into 5. Now what will you observe in all the three numbers? You can observe that all the numbers are having 5 as one of the factor, isn't it? So it means that if a number will ends with 0, then 5 should be one of the factor, isn't it? So if 4 to the power n ends with 0, then it must have 5 as a factor. So let's check we will get 5 as a factor or not. But when you write 4 to the power n, 4 you can write as a product of prime number. It is 2 into 2, which is 2 square. So 2 square whole n if you do, it is 2 to the power 2n. Now how do I get 2 to the power 2n here? So 2 square whole n. Now use the laws of exponent, power law. Okay, power to the power means multiply. 2 into n is 2n. Okay, so it shows that it has only 2 as only the prime factor. It does not have 5 as a prime factor, isn't it? So, and we know that from fundamental theorem of arithmetic that the prime factor of each number is unique. There is no other way to represent. Okay, it is unique. So from here we can say that 5 is not the factor of 4 to the power n. So 4 to the power n never ends with 0. If it has to end with 0, it should have one of the factor as 5. Clear? So this question I have taken from the example question of your NCERT textbook. So that's all for today's class. And if you like my content, please subscribe to my channel and share with your friend also. Thank you.